Hey, welcome back. So in this video, I have two key questions I want to answer. The first is, what is object-oriented programming? What's it mean? And then the second is to define two key terms that we'll hear throughout this entire section, class and object. So we'll see what they mean and how they relate to object-oriented programming. Okay, one of the first things I want to be clear about is that OOP is not unique to Python. Not every single programming language is object-oriented, but most of the popular ones out there are object-oriented. So the exact syntax in Python, just like the syntax to create a variable in Python is different than the syntax to create a variable in JavaScript, but they both have variables. So OOP is not a Python-specific topic. Okay, so next up, what is it? What does it actually mean? So in my definition, I break it into two main components. The first and most important idea is that OOP is just about using code to represent or recreate things that exist in the world, things that aren't in our programming language. So whether that's a car, a user, a poker hand, a playing card, a deck of cards, a casino, really anything out there. And we're not just limited to physical objects. It could be more intangible things, a process, or a song, or a schedule, a calendar, all sorts of different things, but they don't exist built into Python. So we want to create our own representation of that using Python. And the way we do it, and this is the second part of the definition, is using classes and objects. So there's two things. The first, OOP is just about representing things that exist in the world using code. And the second is the way we do that is by writing classes and objects. Okay, so that's a high-level definition. Let's talk about classes and objects now. Two bolded words, very important to this entire section. So the next logical question might be, what exactly is a class? Classes are like blueprints or recipes or specifications. They define what every single instance of that class should contain. So that's kind of a confusing definition. Let's say that we are modeling users. So we would define a user class, and it is a blueprint for every individual user we create. So we set out we define, let's say every user has a couple of pieces of information, which we call attributes. Every user has a username, a password, an email, and a profile picture. But then we also include functionality or methods inside of the user class that says every user has a logout method. It also has a change profile picture method, a checkout method, those sort of things. So it's about taking functionality and pieces of data, attributes, and putting them together into a specification. So every user has this, or every playing card has a suit and a number and a color, is it red or black? And maybe that's about it. But every playing card follows that pattern. It's like a little cookie cutter. And then we can use that cookie cutter to create the individual instances of that class. So we define the blueprint that says every user looks like this. And then when we use the term object or instance, it is an instance of a class. When we create a user object, it is based off of the user class. When we create a list object or a dictionary object, it's based off of the dictionary class. So yes, even though we don't know how to define our own classes yet, we've been working with classes nonstop in this course. So I have Python open in the terminal, and we've been using things like ints or lists pretty much nonstop. So if I type help, if you didn't see the video on help, it's just a way for us to retrieve documentation, information about classes or functions or other things in Python. But let me just do help on int. Notice the first thing it tells me, help on class int. And then we have this class int right here. So don't worry about the syntax yet, but what this shows us right here is the specification for every int. So every int has all these methods. Most of these we don't actually work with, but every int has, let's see, a floor method. It has a, invert, mul, or, rand, all these different things every int comes with. Or let's do help on list. So here's the list class. So this is the blueprint, the specification that says, okay, every list comes with all of these pieces of functionality. And Just as a side note, these double underscore ones that we've talked about are not really for us to use. They are kind of internal pieces. But here, all these list methods we've been working with, append, clear, copy, count, extend, what else is there? Insert, pop, remove, sort. All these things we spend a lot of time covering. Those are defined in the list class. Then when I do something like this, nums equals 1, 2, 3, I am creating an instance of the list class. So when I do type nums, right, I get class list. So hopefully that helps illustrate the idea of a class. It's a blueprint, and then we create instances of that class. I should mention, this is a special little syntax. The classes we'll be creating will create instances by using their name that we create. So we might do something like, I don't know, card equals card. Or we might do something like Alex equals user, and then we pass in, I don't know, Alex, and then something else and some other information. But just to be clear, this is a special case. It's a built-in class, a type in Python. We'll be learning to define our own classes to add in. So I'm actually going to end the video here, but I just really want to hit this point home. Classes and objects. It all boils down to that with OOP. Classes are the schematics. Objects are the instances of that class created using the recipe, creating using the schematic. So from here on out, we're going to learn how to create our own classes, and the reason we do that is to help model things that exist in the real world. So that's coming up next. Okay, let's move on.